Hello and welcome. In the previous video, we talked about post and pre-indexing for load and store instructions. In this video, we will talk about shift instructions. And we touched base a little bit last time when we did the logical shift left, as you can see here, to kind of offset the base address with some number based on this register shifted left, or that value shifted left by 1 bit. And we did talk about briefly also, we reviewed how shifting the bits will actually affect the value that is stored in the register or the value itself. So just a quick recap. If I have, I'm going to have this as a note here. So if I have a 4-bit value, let's say that value is 0010. So this is equal to 2 in decimal. If I shift this value to the left by 1 and it becomes 0100, basically I'm inserting zeros to the right, and I'm shifting the number to the left. This is now equal to 4. So every time I shift left, I am incrementing by or multiplying by 2. I could also have shifted the original number to the right by 1 bit, and this becomes 0001. And this is essentially equals to 1. So the key here is that if I shift left, I multiply by 2. If I shift right, I divide by 2. And notice that before we talk a little bit about more advanced topic here, that I'm inserting zeros, right? Whether if I'm shifting left, I'm moving this value to the left and I'm inserting a 0 here. And in this case, I am inserting a 0, but that's because the most significant bit is a 0. So when I shift left, so this is we call it logical shift left, always inserting a 0 to the right. And when I do arithmetic shift right, I'm always repeating the most significant bit. So for instance, if my original number happens to be 1010 and I'm performing a arithmetic shift right, then the new number will be 1101. Okay, so I'm repeating the most significant digit. It happened to be a 1, and here that's the original digit, and this is the repetition. Okay, if you want to know quickly why that's the case, because when it's in the name, is actually it's arithmetic shift right. From the name, arithmetic means you care about the sign. You're doing arithmetic. So if a number is negative, you want it to stay negative. If it's positive, you want it to stay positive. Oftentimes, when we store the values in memory, a lot of times, for example, one of the instances is we use 2's complement, and the most significant bit will dictate whether or not the number is negative or positive. So obviously, if you are multiplying or you're dividing that number, you don't want to go from a negative value. Like you can't go from 2 divided by 2 and get a positive 1. Like you can't go from -2 to +1. So you want to go from -2 to -1. And if you need more tutorials on that, or if you need more help, let me know. Maybe I can. I believe we covered it a little bit, but if not, I can do a quick example and show you that the 2's complement of this number and this number will be equal to 1/2. So whatever that value is, if you take the 2's complement of this and get it in decimal and do this one, the bottom one will be half as much as the top one, and both numbers are negative. Okay, without spending too much time on that, let's do a quick program. So let's move a value into register R1. Let's move the value of 16. And then we're going to do logical shift left of that register by the amount of, let's say, 1, which basically is going to move those, divide the value by 2. So let me move that number. Actually, left is multiplying by 2, sorry. So let me move the value of 16 into R2, and then we'll do arithmetic shift right on that register by the amount of 1. We'll compile and download this to the board. Okay, went through. Okay, so I'm going to run the program down to here. So I'm going to move the value of 16 into R1. 16 decimal is equal to 10 hex. That's my 10. So if I'm shifting it left, I'm essentially multiplying 16 by 2. So I should get 32. And 32 decimal is 20 in hex, right there. I can also display, well, let's go through this example first. And then this is R2. I'm going to move 16 into R2, and 16 is 10. And now I'm going to shift it right, arithmetic shift right by 1. So this should be 8. Here we go. This is my 8. I can also show you the content in binary. Perhaps it may make more sense to you. And I can restart the program, run down to this instruction. So if I move 16, maybe here you can see it, 16 is 10000, and I'm going to shift it left. So you're going to see this 1 moving 1 bit to the left and a new 0 appearing to the right of that number. And then here we go. Now we have 1 and 5 zeros next to it. And then for R2, I'm going to move 16. That's my original 16. And I'm shifting it right by 1. So I'm dividing that by 2. So you'll see 1 and then 2 zeros, 3 zeros are next to it. And then the 1 0 will be repeated in the most significant bit. Here we go. There is one more instruction that is called the rotate right. And the way you write it is rotate right R2 and specify the amount you want to rotate that value with. And rotation essentially takes the bits from the least significant figure and then push them back to the topmost or the most significant bit. As the name suggests, you're rotating right. So you're not using any new bits. You're simply rotating all the bits. Okay. So let me do this, and I'm going to do it multiple times. So hopefully this will be displayed better for you when we run the code. So I'm going to do this, let's say 4 times at least. 1, 2, 3, 4. I'm going to download it to the board, and then we'll step through it. Okay, so I'm going to run the code actually straight to this arithmetic shift right. We have seen the other stuff before. And here we go. So arithmetic shift right of R2. This is my R2. Has 1 0 0 0 0. So arithmetic shift right. We dropped that 0 and inserted the most significant bit back into. I'm sorry. We dropped and we inserted we repeated the most significant bit right here. Now, when we do rotation, you're not going to see much difference here because we have 1 0 0, and that least significant 0 was actually rotated all the way back to the top. And if I keep doing it, you will see that it's getting smaller, and then eventually that 1 was dropped from here and then pushed all the way back to the front or to the beginning, right? So when you do a rotation, when you rotate right, the bits will be dropped from the lowest or the least significant bit and go to the most significant bit. If you're doing an arithmetic shift, the bits will not be reused. It will be dropped out, and the most significant bit will be repeated. And that is the difference between arithmetic shift right and a rotate right. And then the last or the first thing we covered was the logical shift left. And in that case, you always insert a 0 in the least significant bit. Thank you for watching.